Hello and welcome to the DataEng meetup, the online DataEng meetup. We're a combination of the Brisbane, Sydney, and Melbourne data engineering meetups, and we're really excited to have you for another edition, the September edition. Can you believe we're already in that month already? It's this year has flown past, and a fair chunk of us are still in lockdowns, but hopefully soon to be let out in the next couple of months, which I'm really excited about. But in the meantime, we've got an awesome lineup of speakers for you this month. So we've got Brian Olsen Jr., first cab off the rank. He's a developer advocate at Trino and Starburst. He used to be a US Marine, would you believe? And then he turned into a software engineer and developer advocate. So I think that'll be pretty cool to hear his background and story. I think that'll be wonderful. And then we've got Anna Abramova. So she's a software executive and business leader at SQL DBM. That's a really cool data modeling tool, and she's got a wealth of experience helping innovative SaaS companies conquer, the market. Going through rapid growth. So we're really excited to have both of you present today. That's going to be really awesome. Obviously, we've got DataEng Bytes, our annual data engineering conference happening next month from the 5th to the 7th of October. We've got some of our speakers already up on our website, so that's going to be hugely exciting. So go take a look and let us know which speaker you're really excited about hearing from. We're going to have some cool keynote announcements happening shortly as well. So that's really cool. You'll see we're going to do a bunch of social media posts in the coming days with all of our amazing speakers and lineup. I think it's going to be a really great bunch of fun. We would have loved to have done it in person, but that's kind of the way things have rolled this year. And who knows, maybe next year, 2022 is the year of in-person conferences, perhaps. But enough of my rambling. Actually, have you checked out my awesome DataEng Bytes 2021 t-shirt? We'll try and get a few of some of these out to you. Perhaps if you ask a really awesome question of each of our speakers, we can get you in on the action. And it's just private messaged me and said she loves the t-shirt. That's awesome. Thanks for the vote of confidence. But I'm going to add in Sir Brian of Trino fame.
Hey, how's it going, Peter?
Do speakers get some? Well, why not? Let's ship them over. So you're going to take us through Trino. Trino used to be called something different, didn't it?
Yeah, we're going to go into a little bit of that. So if those of you who are kind of familiar with Presto, we're going to dig into a little bit of that history there. I'm going to try to do it in the least boring way possible. It's going to be somewhat a review for, I think, a good chunk of you. And I like to just go through it, though, just to get everybody on the same page. So did you have anything else, Peter, before we hop on? I got to say thanks for the awesome welcoming intro.
No worries. I will. I'll let you go for it. Take it away, Brian.
Awesome. All right. Thanks, Peter. Hello, everybody. I'm Brian Olsen. I am a developer advocate at Starburst, also a former U.S. Marine. Did a whole bunch of computer stuff when I was, hanging out in the Marine Corps. And I don't know, I think eventually just stumbled onto getting into a software engineering degree. Did a database course somewhere along the way, and then just, got all into the data engineering. I was right around when I was in college, was getting right in the early days of Hadoop. So you get some context of where I'm at. So I also do contribute to Trino. That's kind of how I got into this gig. If after the talk, if you all want to get a hold of me, I am on Twitter at bitsondatadev, and you can follow up with any questions there. I'm also just joining the data engineering Slack channel, so I did just hop on there if you all have any questions for me after this. So yeah, so today we're going to be talking about Trino. We call it the ludicrously fast query engine. I'm not sure if any of you are familiar with the Spaceballs reference there, but check out Spaceballs if you're interested in figuring out what ludicrously fast means in this context. So bit of an overview. We're gonna do a Trino TLDL. I say DL because it's going to be too long to listen. If you just want to get the main source of what I'm going to be talking about in the first slide here, and you need to get back to some sort of, I don't know, something's on fire, or you're setting up your own presentation for tomorrow, just go ahead and just listen to this first slide, go to trino.io, and then, move on with your life. And then you can come back in about 20 minutes whenever Anna talks. And then after that, we're going to jump into a bit of the history after I do that overview. Talk about some of the features that I think are kind of like the real key pieces of why Trino and originally Presto got so much adoption and why it's so popular today. And then talk a little bit about, kind of give you a hint at some of the ways that Trino fits into these various architectures that are commonly discussed today. So without further ado, I might just realize that is my thing not changing? Looks like there we go. Okay, that's the ticket. Okay, so sorry that you all were not seeing my slides update. Thankfully, I caught that just a second ago. So apparently I have to be on the screen in order for the slides to update. Okay, cool. So Trino TLDL. We are talking about Trino. It's a fast distributed SQL query engine. So what does that actually mean? So we look at a query engine. It's not actually going to be storing data. It's actually going to be sourcing data out to many different databases that stored in many different ways. And so basically, it could pull anything from like a real-time system, like say Pinot. Its primary use case originally was to kind of query over, run as a query engine that sits over your data lakes. So in that particular case, say like Hive or a new format that's coming out now called Iceberg, you're actually able to run queries over these data lake technologies or these data lake table formats and retrieve that data back. It does all of the processing in that case. Now, when you're looking at data sources, say NoSQL databases and traditional SQL databases, it's actually going to be trying to push that data, that query down to the data source itself, and actually run the query locally, and then bring that up into the results from each of those into Trino's query engine. At that point, it's actually going to be performing the rest of the query. Say if you're doing a join across, say, MongoDB or Hive, and Hive or data lake of sorts. So Trino has two pieces. It's two primary types of nodes. One's called the coordinator node, and the rest are called workers. Coordinator handles interfacing with metadata. So for instance, metadata of let's say your Postgres database, it's talking to the information schema, getting all of the logs, any type of statistics that it can pull from to kind of do better optimization for its own query. It's going to be pulling that directly from the data source. So coordinator does that during the parsing and analyzing as well as planning. And then it also, coordinator is then responsible for scheduling the query and actually how it actually runs all of the distributed pipelining and things like that, so that, if you have, let's say, your data distributed across multiple nodes, Trino can take advantage of that and actually execute, do a pushdown query, talk to, let's say, 4 nodes on the source side, and then it can allocate 4 of its worker nodes on the pulling it into Trino's worker node side. So then that's all happens in the coordinator and in the kind of parsing and planning steps. And then at that point, once the schedule's set up, it then distributes those schedules across all the worker nodes, and then they individually talk to all of the data sources, aggregate all the data, basically do all the processing through primarily like hash bucketing, things like that, and then returning those results back to the coordinator, ultimately back to the Trino client. What's really cool about Trino is that it has from the beginning, and we'll dive into a little bit more about this in the history. It really exposed the focus on standards and exposed this ANSI SQL is a language, so that anybody who's interfacing with Trino, as long as you know SQL, particularly as long as you know like the same SQL that, let's say, you'd use in Postgres as they follow ANSI SQL standards, then you're going to basically be able to run the majority of those same types of analytics queries on Trino as well, using just ANSI SQL, the same kind of stuff that most people in the business know. So there's a lot of focus on keeping up with the standards. We have all the way from the 92 standard all the way up to the pretty much the latest 2016 standard, all focused on primarily the analytics side. We'll get into this as well in a second, but we don't do any of the transactional nature of the of ANSI SQL, but primary focus on the analytics part of the language. But everything, it's not like one of the big drawbacks, say, of various databases is that you have to learn their flavor of SQL or their flavor of some graph language and things like that. And that can be good for maybe us engineers, but when you're trying to expose it across the entire business, a lot of times this can be a big pain in the butt for getting different teams on board with with using this. So that was another big big thing about Trino. So that's kind of the overall overview rundown of Trino. We're going to dive into the history now and kind of understand why it does what it does and why we're primarily focused on OLAP. So one of the things that I really liked, I don't know, maybe a lot of you are familiar with this book, maybe not, Martin Klebman's Designing Data Intensive Applications. It's the little book with the hog on the front. It has a lot of these cool little maps, and I really, really enjoyed this part of the book. I'm a very visual type of person, and so I liked taking all these large spaces, which we constantly have to learn more and more and more as data engineers, figuring out what the heck, there's a new technology that I have to know where it falls into this whole map. And so I always really liked how he took this kind of generic map making and divided things up. And so for us, for our conversation today, we're going to talk about these two differing sides, the Kingdom of Analytics and the Republic of Transactional Processing. And so what that actually means is that if you're looking at this is probably not the first time you've heard this, but you have OLTP and OLAP as primary segregation between a lot of the database space here. So OLTP is primarily focusing on transactional insertions, updates. You're trying to make sure that you're keeping some sort of business logic intact, and you have this volatile updates that are coming through, and you want to make sure that if somebody's reading that, based on the level that you have of basically isolation that you have, you're going to have some sort of level of expectations on how writes and reads will occur in various orders. And that's going to, probably take more processing power or slow things down a little bit more. But, that's ultimately trying to keep this source of truth in this very correct state. OLAP, on the other hand, is just throwing that all out the window. And for the most part, it's just saying like, hey, let's focus on getting these reads really fast. We're not going to be updating this. We're just going to be throwing a whole bunch of copies of these OLTP states of these OLTP databases or these, any kind of, let's say, just big data in general, you want to say. I don't have a better word for it off the top of my head right now, but basically just videos or, big giant JSON files, who knows. And you want to throw that into some area to get processed for later. That's going to fall under OLAP. And then you have all these kind of other things that I'm putting in this other category, like just document stores and key values, are more focused on like running databases for applications and things like that. So we're going to just put that in a slightly other category. But for our purposes, we're going to be focusing on that middle category, that OLAP category. And this is really where Trino aimed to fix a lot of issues that were there. So let's go into what those issues were. So OLAP kind of came around. You may see some of these things and kind of remember this was the stuff that was going on in my world whenever OLAP was a newer thing and really becoming hot. Now, it was newer back in the 80s, late 70s, early 80s, but it really started to gain popularity in the 90s when this data warehousing concept was taking off. At this time, we were all walking around with our Walkmans and CD players skipping around. I was playing Eiffel 65 Blue Dabba on repeat. And, the only databasing I was doing at the time was with my Pokedex. So the basic thing was that, they were just trying to get these copies of your business logic or your OLTP databases into another database, try to get them from different, like, let's say across different accounts, or let's say marketing, sales, all these other different departments, and get them into one location. So they did that by pulling that into a staging area, transforming the data, and then loading it into one database to rule them all, which was the database data warehouse. So this was, interesting and definitely, a very, very popular method for a really long time, but it was incredibly slow. And, but it was okay because this was just kind of internal business analytics going on. And the business, as long as, things were updated the next day from the previous day, it was okay, right? But one thing that was not, totally, this didn't totally take account for was the kind of Web 2.0 stuff coming up along the way. So, Web 2.0 came up, and it was really focused on, social media started blowing up. Everybody started putting their videos up on YouTube. People started to get phones and started doing all sorts of crazy things with, messaging apps and all sorts of things, and constantly being online versus, occasionally being online when they got home for an hour. So Web 2.0 just brought a whole new revolution to how much data we were dealing with. And so now we were not only dealing with a slow data warehousing solution that was, at the time vertically scaled, but now we had to figure out how do we actually keep up with all of this new data. So, the answer, as we all know now, is rather than scale vertically, we needed to scale horizontally. We needed to basically make sure that if something went wrong, we didn't have everything on one single node. That was going to basically, one thing went wrong, it just took down the whole operation, right? So that was one thing. We needed that commodity hardware to basically be able to get easily replaced, and then, just replicate the data so that way if one thing goes down, the data is still available, right? The other thing was, we needed to make sure that we could actually insert this data and get the huge amount of new data that was coming in, and actually get that out in parallel. So this is this initial drive to push us into distribution. So, that's great. We now have this new problem. Not only are we, slow, but we're hella slow. And what's worse is that, Hadoop just came with this thing called MapReduce. And that means you just have to write your own Java code so that you can actually process all this data. So what ended up happening is people just started throwing all their data in there and saying, well, we got to figure out we got to wait to hire at least 50 people to write MapReduce, and then, have them all flux in and out constantly, and then not know who wrote the last MapReduce legacy product. So you just keep rewriting new MapReduce products. I'm sure a lot of you remember this kind of cycle in the early days of Hadoop. So, that got old really super quick. So fast forward to 2008, Hive came around. So Hive was the not perfect, but the Hive QL solution. And so this was actually coming out from developers at Facebook. It was the very first SQL on Hadoop solution that basically gave you a SQL-S type language and gave you the ability to just transfer any type of this SQL stuff into MapReduce, basically the MapReduce code that needed to run on Hadoop. So great, problem solved, right? No, this was ridiculously slow. This still had that same initial problem. At least people were able to write queries now, but like the queries would maybe run, at least in the early days of Facebook, it was running. Data analysts were saying that they could. It was a good day if they could run 6 queries in a single day. So this was still a problem. And again, let's keep honed in on Facebook, because the next step to this actually happens as well at Facebook, which is Presto. So Martin Traverso, Dane Sundstrom, and David Phillips in 2012, 4 years after the creation of Hive, came to Facebook, and they created this engine called Presto. So these guys had actually worked together before they got to Facebook. They had some previous work with this data warehouse called Netezza, and the thing that they really all liked about Netezza is that this was like a drop-in like hardware solution similar to like Teradata nowadays, and you basically just put this one hardware piece inside inside your local installation and just plugged it in, and everything just worked. So this was something that you did not see in the open source side. And anybody who was trying to adopt the Hadoop ecosystem and do all the things there, they were just not, it wasn't there. And so they wanted to basically make something that was a Netezza of open source. Obviously they wanted it to be open source and have this neutral governance model. This was very important to them. They figured, anything that they created at Facebook, if they didn't open source it, it was just going to get locked into Facebook. Facebook was going to use it for their own purposes, and it was never going to see the light of day. So, they wanted something that was actually going to live on the test of time. And so the only way to really do that was to open source it. And, early days, 2012, this was no problem. Facebook's like, yeah, sure, whatever. Fast interactive analytics, at this time they were dealing with Hive. Everybody was really sick of these slow query turnarounds and not being able to just run queries when you're thinking of them. So, this was a lot of issues, right? So Presto was going to be aiming to basically replace that Hive engine and put in place of it a new engine that still utilized the same storage and the same metadata layer, but just basically replace that really slow MapReduce generation stuff going on in the early days. And then, obviously correct results. That's always super nice. Anybody who's worked in any of the Hortonwork, Cloudera, Frankenstein type of Hadoop installations, you all know that, sometimes correct results was too much to ask for. So, again, not too much hate against Hive or anything. They paved the way, but yeah, it was definitely rough days when, you just kind of had random garbage data getting written into your Parquet file or something like that. Standards based, of course, as I was mentioning before, ANSI SQL, JDBC, all these standards, like, let's just focus on the standards. Who cares how old they are? Who cares how, clunky it is? And there's a much sexier new standard. Let's go with the tried, tested, and true types of standards like ANSI SQL, JDBC, and various others that they implement internally that are more focused on getting something that has been iterated through over years and years and years, and has a lot of adoption at this point. So that was really the big drive for Presto, and it was a great success. It was had a lot of quick, immediate turnarounds where Presto would basically replace that Hive engine, as I was telling you. You'd point it to the same metastore. Hive had this thing called a metastore, and that was like the one remaining service that would live alongside with Presto. And then you would just point, and then that basically would point out to your HDFS storage, and eventually they incorporated the S3 cloud storages as well. So this was awesome, right? Like and as things going along, we now have this fast query engine. We can interactively query the data with this very standardized SQL language, and use anything that supports JDBC. Any tool that supports JDBC now can use that. You can build. They built Python and a couple other tools that clients that talk to that. So everything was awesome, right? So let's go right to the drama. Trouble in paradise. So 2012 they open source Presto. 2018, 6 years later, Facebook kind of puts this attempt to unilaterally make this decision to take over the project. It was becoming super popular. They wanted to basically take a little more control over how much stuff got put into it, and they actually just wanted it to use it for what Facebook needs in priority. And in particular, the one example that is kind of reiterated in a couple blogs that we've written about this is that they were automatically kind of giving the committership rights to anybody who was working at Facebook, and that same thing wasn't happening for anybody else in the community. So just not a healthy set of standards or not a healthy ecosystem to be running your open source system in, right? So founders quit, they go create the fork. So what ended up happening that was kind of crazy after this, though, Facebook, after the fork later that year, Facebook applies for a trademark for Presto. They make a Presto foundation that is built around that is built in conjunction with the Linux Foundation, and ultimately they applied the trademark and threatened to sue and all this stuff. And then the Martin, Dan, and David basically had to rename Presto SQL. We were calling it basically the forked version Presto SQL. The original version was called Presto DB, named after the names of the URLs or the websites. And basically Presto SQL at that point then became Trino. So that is the whole background. It's not the first time, and I do want to point, most important thing to pull from this is that, although the companies do try to do these things, sometimes it's not the companies that actually run these open source projects. It's really the people that are behind it. So, and it's not the first time we've seen this either. And those of you that are familiar with the whole Jenkins and Oracle Sun, it was Sun, then became Oracle issue, this is the exact same thing, just a whole different day, So I'm sure plenty of you who follow an open source stuff, you see this stuff all the time. And so just one of those things. So ultimately, Trino's been doing great since the split. This is kind of looking at between the two projects. Martin, Dan, and David are still running the Trino project. Velocity's been growing for a lot of the committership as well as community investment. And since the rename, we had an initial time where we were trying to, and including now, I'm trying to tell, hey, Trino's the new Presto. Basically, there was a little bit of a time with the rename. It was a little bumpy, but for the most part, people are starting to get the gist of which project to go to and this kind of thing. And so more or less, this is where Trino sits today. We're still adding a lot more new features in there, and as you can see from the commit graph over here, we've been doing a lot faster than the Presto DB project. So let's go jump into some of these features. I'll have to try to speed up a little bit. I went a little long with that history lesson. And let me just tell you real fast. This is the Trino mascot, Commander Bun Bun. That was named by one of the engineers' daughters. So we did a community vote, and that was the name that came in, of course. And so awesome. I actually was really happy for Commander Bun Bun. But anyways, that's our new little mascot. So one of the really cool things that I like to think about with the big features that makes Trino super, super popular now is in the early days, Facebook had their specific internal open source versions of all these projects. And then they also had, when Trino was trying to get open source, they tried to basically have support the, open source Apache Hive, open source Apache Cassandra, and Postgres, so that people on the open source side were also able to use that. So they had to basically start maintaining two different code bases for each of these different data sources. So initially, this was they created this layer called the SPI that just had a connector type framework. And the funny thing, and a lot of people just don't know this, and I didn't know this until I asked Martin, Dan, and David about this, but basically this was not the initial plan. Like, this was not the design for Trino to have this connector framework. It now allows you to do all this really cool stuff like joins across Cassandra to Hive, which was just a total byproduct, and do even cooler things like for those who are familiar with DBT, a lot of you know that you can't talk to multiple data sources within one DBT setup, but now with Trino, you are actually able to read from two. You can't write to two yet. We're still working on that one, but you can read from multiple data platforms using Trino. So it's just really cool, some of the stuff that this unintentional feature ended up opening up, and it's actually one of the primary drivers as to what made Trino super, super popular. Trino is a ludicrously fast query engine due to the MPP architecture. So it does split, when you're running a query, you're splitting up a lot of these different data sources across nodes initially. So you're doing internode splits. And then once you are, within the node itself, you just, it's a multi-threaded type of setup. And so they do also intranode. And there's also custom generated, basically custom generated JVM code that runs real time for every single query that's written, that executes, so that it executes basically as efficiently as possible across these threads. So like, there's a lot of engineering rigor that goes into like what, this whole MPP architecture that makes Trino super, super fast. It's not just, the fact that it did away with like, for instance, compared to like, let's say Spark, it doesn't do a lot of the data, shoot, lost my train of thought. It doesn't do a lot of the fault tolerance pieces. So it's not like writing back to a database or checkpointing or anything like that. That's another one of those speed ups, but it actually has like a lot of the engine itself, like being super, super fast. Later on around, I'd say like 2017 or 2018, the cost-based optimizer was added. And so this is also, taking in, various tables. So if these tables are, let's say, across different data sources, it's going to, pull in these stats from all these different data sources and basically ultimately determine, I don't know how well you could see these, but basically, if you have some table that is, essentially on your build side, that's going to be read into all into memory. You want to try to make sure that the table that's on the right side is as small as possible. So cost-based optimizer is going to push that to the scan side versus your build side, right? And so same thing with the optimizer if you're going to try to push down filters, things like that. So this was something that didn't exist also in the initial phases of well, at the time Presto, now Trino, and so this is just yet another really super awesome feature. A kind of note that I want to make too, for anybody who's going to go out and try Trino after this, there's a little bit of a thing you want to pay attention to in terms of the containment hierarchy. So a lot of times people that are used to like a traditional database, you have like a database and a table, or in Mongo it's a database and a collection. In Trino, I just wanted to be very clear, they have a higher level, third level called catalog. And there's technically in the containment hierarchy, you can go like cluster and I think business as well as a higher hierarchy. But most databases usually only stop at these two. So I do notice a lot of people do find that kind of confusing at the beginning. So if you want to talk to let's say your Mongo catalog, and then you want to talk to the, transport schema and then the flights table, then you're going to have to, do this. And that's, you can also set those just the same way that you would in MySQL or Mongo, just, setting it in the CLI or something like that. Just wanted to make that as a kind of a quick side thing. And then the final thing, and I didn't have a slide for this, but the final feature that really puts it over the top is that SQL compatibility. So let me go quickly over these couple architectures where Trino really fits and does a lot of good work. So in general, data warehousing, if you're running a data warehouse like Teradata, you're in one of those Hadoop warehouses like I was talking about before, or even if you're in like just Snowflake, in this particular case, I'm not saying that you shouldn't have any of these things. ETL and data warehouse is like a super, super important thing. But the typical, advertisement around Snowflake is just put everything into Snowflake, or put everything in Teradata's way is like put everything into Teradata, put everything into one location. And Trino is kind of a backdoor to basically not have to do that. If you want to have analytics that is kind of spanning multiple data stores, then you can ultimately, avoid having to do this vendor lock-in kind of, move everything to one location and then everything's going to get fixed kind of thing. You can still have your data in Snowflake or still have your data in Teradata and Hive or whatever. But then you can also just let certain data that you don't want to do ETL processes on or move everything around. If you don't want to do the ETL, you can basically just run ad hoc queries using Trino along with the data warehouse. So characteristics of data warehouse is that you're imposing some really heavy schema. So that works perfect with Trino because, again, we do the ANSI SQL. It works super, super well. ETL, you're going to have to wait a little while before the data actually shows up. That's, again, one of those kind of drawbacks to doing data warehousing in general. And then, so Trino decreases the latency due to that MPP architecture stuff I was talking about before. And then, you can do things like augment your historical data with really fresh sources. You also have heard of Data Lake and Data Lake House. I kind of lump those together because we practically we skipped the step of just Data Lake and went to Data Lake House. The only difference is that this was a Databricks construct where it's like you just store unstructured data instead of structured data. And then you basically, went from one step where you were just having a combined compute layer doing ETL still, or ELT. And then, Data Lake House basically made it where they just had a compute layer using, Spark SQL or something like that. Trino is essentially, a very solid and faster replacement for Spark SQL. So in general, we give up the whole fault tolerance. We don't do checkpointing, but we basically say that, in general, most of the queries in production and across the board, we don't see any of the really problematic things that you saw in earlier iterations of big data systems. And, if there is a breakdown, it's usually, something that's so fast that, within under an hour or something like that, that restarting the query really isn't too heavy of a penalty. So we make that trade-off. Of course, if you start going higher in latencies, that might be more of a candidate to kind of do ETL and something longer. So we do one, I'm going to skip through to the last little thing, and then I'm done because I'm definitely going over time right now. The last one, very common one we're hearing about these days, data mesh. I wouldn't say I say we're a part of this, but this whole stack that we're kind of envisioning for what could work with Trino is still kind of in the works. There's 4 tenets that you have to meet with data mesh: domain-oriented, decentralized data ownership and architecture. Trino really lets any domain use whatever they want. So you see all these data sources here. Anybody who's using their database setup, let's say they're using Mongo for their application, or they're using Elasticsearch so that they can do fast searches, that data doesn't have to get moved around anywhere. And you can basically just leave that on, a whole separate domain segmentation of your architecture, and you just connect into it with Trino. So that definitely supports that. Data as a product is not really what Trino provides. So, we say Trino via Amundsen and Atlas. Atlas now gives you that discoverable, Atlas and Amundsen together kind of give you that data discoverability so that you can have that data as a product with all the documentation and everything around it, so that, people can actually find what they're looking for in this huge, web of things that you'll have coming from your Trino single source. Self-service data infrastructure as a platform is the third tenet. And, Trino can obviously be that single point of access, and is a really nice area where people can actually, get provided that kind of data, like they say, like a data fabric, or basically somewhere where you can piece together all of these things, and so expose it through that SQL API, and that then becomes that self-serve data infrastructure platform piece. And then the last one, which is the most floozy one that we don't really have a great answer for. I don't know if anybody has a great answer for this one, but the federated computational governance. Security and Apache Ranger definitely falls into something that can help you with federated security on what gets access and what can't get access. But outside of that, in order to actually have the full scale of what Zhamak, the creator of Data Mesh, kind of describes, it's not there yet, and I haven't really seen anything in open source land that has been able to address that. So I'm going to leave it at that. I'll just say that it's in progress, and I think Trino can definitely play a big part into a data mesh strategy, and something definitely for people to check out. Last thing before I go is, we have a very awesome, vibrant community. I hope this talk helps you kind of get a bit of a glimpse of like what Trino is. And so if you want to, learn more, we definitely have the Slack channel. If Peter, if you can, I don't know if you already have shared this or not, but if you could share the list of links. I have one link called Community, and it has all of the like Slack and this Trino community broadcasts and all the meetups and everything listed on that page. If you want to contribute to the project, definitely reach out to us on Slack, and then also go to that trino.io/development. And we also have a Trino Summit coming up in October 21st. Definitely come check that out. I'll have a link to register there. And with that, that is my presentation. I'm so sorry for going over 5 minutes. I said it was going to be closer to 25 minutes, so it was more like 30. But yeah,
all good. We love hearing from excited speakers and developer advocates. There's a wealth of information that you sent through. So that was awesome. Thanks so much for sharing all of that information and also the history. I was keen to kind of get the lowdown on what went down about between Presto and Trino, and sounds like those sorts of things happen, don't they? Cool. So I'll just have a look at some of the questions. We got a comment from Suba Reddy. He said, we are using open source Starburst Presto, so that's really cool.
nice. Yeah.
So got a few people already out there in the community sort of using it. Simon O'Toole, he's going to be a keynote at DataEng Bytes. Does huge amounts of work with astronomical data here in Australia. So he's using Presto and planning to upgrade to Trino in the coming months.
Awesome. Reach out to us for sure. If there's a blog on it. If you're not on the Slack already, just reach out to me. I'll send you that blog. Let me know if you run into any issues. For the most part, there's also a LinkedIn episode where they talked about their upgrade, and it was mostly a couple clients that they had to make sure got the upgrade. But outside of clients making sure that those JDBC artifacts get updated, that's really, I think, the only kind of messy part where you have to go around one-to-one. But
yeah, cool. Ravi asked whether there were any comparison analysis done between Trino and Snowflake.
Yeah, so the primary time where you're going to compare Trino and Snowflake, like they're very different. So Snowflake actually has its own proprietary storage. So when you store anything into Snowflake, once it's in Snowflake, like Snowflake is pretty fast and it's awesome, right? We are cool. Like Snowflake is awesome, and we think people should definitely use Snowflake. It's definitely a future data warehouse platform. Where Trino and Snowflake kind of bump heads a little bit is Snowflake is kind of pushing put everything no matter what. Like if you have data that falls under the OLAP scenarios, put it all in Snowflake. And that's where we kind of differ. And they have this one kind of workaround. If you don't want to store in their proprietary format, you can still store in S3, and they do kind of this like offline table query. And that's where you would actually want to do a comparison between Trino and Snowflake, because that's where they could, technically do a join across a data lake and their own data. So Starburst has a couple internal ones. We don't like to publish them because Snowflake is also a partner of ours. But if you do want to basically work, or we can give you all the kind of information you need on a one-to-one basis and kind of send it over to you. In that particular case, the Snowflake falls flat on its face when it's trying to read from S3 data. It was built to read from its proprietary, built for the cloud, right? Snowflake is 100% built for the cloud. Its proprietary data stores are built exactly around all of the S3 and equivalent setups there, and how they store all that data and compress it and everything. So it's 100% tuned for cloud. As soon as you get away from that use case though, and you need to go do something else, that's where we say bring in. So use Snowflake for that 100%. And then when you aren't doing the ETL, where you need to scan every single bit of the data, and where ETL doesn't make sense, start using Trino. And then Trino can actually, and so open source Trino does not have a Snowflake connector yet. Starburst does, but you can actually do a federated join over your Snowflake data and your data lake and any other data source. And that's where you would want to start using Trino. So, the one comparison that would be there would be the join between the offline table of Snowflake and their own data. And it's not a very performant way. Snowflake's not built to do that.
Yeah, it sounds like horses for courses. I think Snowflake's a wonderful tool, data warehouse technology, and Trino likewise. So whatever fits the use case really.
Totally.
But that was cool. And just finally, Vinay Kulkarni just asked, keen to understand if you've assessed any other data lineage tools along with Apache Atlas.
Yeah, Apache Atlas is a garbage kind of, but that's our the best thing we have with the whole, kind of fitting in with the Apache Ranger pieces. And so the one I would say I know the enterprise version, it's DataEng, and I'm trying to see if anybody knows anybody type in it starts with M. It's like Marquez. I think it's Marquez.
Yeah.
Yeah, so Marquez is pretty awesome. I want to keep looking into Marquez as a viable option. But right now, in terms of like cross compatibility across tools, Marquez is kind of on its own little silo right now. And so I'm really interested to see if Marquez can start integrating with Amundsen in particular, and if they can start integrating with some sort of like, I want there to be a replacement for Ranger, to be honest. Like Ranger sucks also. And so if we could get to where we could actually like replace Ranger and replace Atlas, like that would be the best. And so I could see Amundsen, Marquez, and like, fill in some cool open source technology that maybe one of you will go and invent tomorrow and replace Ranger, please.
Yeah, it does feel like the lineage and governance sort of space is crying out for a really cool open source solution that sort of brings it all together, because they're all kind of similar. They all need to rely off like information schemas and metadata to sort of do their thing. But anyway, we are a little bit over time. But that was really informative and lots of great questions, Brian. So thanks so much. Don't be a stranger. Feel free to pop on by,
Sure, and everybody, we're almost to 4,000 stars on our GitHub. So if you can go over there and just get us above the 4,000 stars, please go ahead and give us a couple stars on GitHub, please. All right, and that's it.
Awesome. Well, Simon just joined your Slack, so
Awesome.
I'm sure that'll help. Cool.
I'll talk to you soon, Simon.
Awesome. Thanks, Brian. Okay, on to our next presenter. We have Anna Abramova. I hope I've pronounced your name correctly.
You did. You nailed it, actually.
Boom.
I love
there we go. So SQL DBM, it's kind of like a bit of a data modeling tool, and it looks actually really cool. So you're going to take us through a bit of that?
Yeah. So, Brian, don't worry. Don't worry about going over time. I really love the history piece that Brian covered. Actually, was a good kind of learning for me. Even like I feel like I didn't know some of the things. So thanks, Brian. Thanks, Peter. Yeah, I have a couple. I don't have like a traditional slide deck to share, but I do have a couple of things to walk people through. So let me start sharing that, if that's okay.
Yeah, sounds good.
Perfect. Okay, how's this? You able to see it okay?
Absolutely. Yeah. Oh, mirror board. That is very sort of cutting edge, isn't it? Love it.
Yeah. So I'll try to kind of go with the flow of the mirror board.
Yeah, I will let you go for it. I'm just going to hide a few things and drop off the screen. So without further ado, take it away, Anna. Perfect.
Thank you so much. Cool. So my name is Anna Abramova. I am kind of taking lead at SQL DBM for everything responsible for growth, customer success, and sales as well. So kind of different organizations that I look after. And I'm actually dialing in from California, San Diego, California. So on the other side of the globe, which is exciting. The sun already set for me, but I guess you guys just starting the day. So I'm representing SQL DBM over from California, and SQL DBM is a SaaS solution, online database modeling tool. I won't cover it. I promised Peter that I will not do a sales pitch, so I prepared something different. I actually was a little bit hesitant in the beginning because Peter was like, hey, Anna, let's just present for us for the DataEng meetup. And I was like, well, I'm not really a technical person, right? If you look at my title and the things I do, I'm more on the business side of things. Yet then after thinking about it for a bit, I figured there are probably a couple things I can actually report on, maybe some trends, maybe some things my team is hearing from customers, maybe some trends about solution. Our solution is an example, and then the rest of the modern data tech stack. And so I'll try to do that, kind of like using my business background and applying it to the tech world we're in today. The big problem that I know many folks are aware of is that communication gap between business and the technical users, IT team. So there are probably like a ton of memes about that on the web. I picked one from folks at DataEng. They're in a similar space that we are. It just kind of feels like sometimes you need a translator between your business and IT folks, right? And I do know from what my customers are sharing with us that almost every data engineering task is tied back with a business problem. So those things aren't really separate. They really are. One helps the other. So we use data now to make decisions, and both teams, camps are actually essentially got to work together. So let's see kind of how this is happening, how it's how maybe I can share some knowledge that would help you guys. You're more on the technical side, right? Maybe I shed some light on what business people have in their mind. From my perspective, you can probably see it on my LinkedIn. I've worked mostly in SaaS companies. I was at an online marketplace. I was at an API connector company. I even ran a vegan desserts company back in the day, so it was fun. I actually attached a picture. I had bubble waffles at the stores that were all around California. It was fun. Very tasty, by the way. And kind of now working with data teams, yet having that experience of like owning a product, I kind of do get both of the worlds, hopefully. I guess you tell me if I'm wrong or right. And so what do I do today? Today, my role is mostly about being more like a customer advocate, maybe. SQL DBM is an online solution. So we're SaaS-based. We have clients, customers, users all over the globe. Probably every country, you think of, we got a user or two there. Mainly, of course, it's US, Canada, Australia is popping up ridiculously. There's so much adoption. That's why, if you use SQL DBM ever before, please give me a shout. Let me know how it was. So my role today is, my team takes care of existing customers, new customers, and then partner relations. Just like Brian's team, we're partners of Snowflake Data Cloud. I also work with Microsoft Azure Synapse Analytics, AWS Redshift, folks like those. Screenshot from SQL DBM's website. If you're interested, just type it up, go to sqldbm.com. You can click this button, try modeling, and see what the tool is. So I'm not going to sell you on it. Probably useful if you're using one of these names down here for the database or data warehouse solutions, and you could use SQL DBM to visually represent those. But interesting thing is, specifically how it's for a team. And I see solutions these days, they're not really standalone solutions. They're more like creative for collaborative work, because as I mentioned before, it's not like your business folks sit in one camp and your IT team sits in another. It's kind of a mishmash. Obviously your cloud data platform or data warehouse or whatever you kind of storing things would be kind of in between the two. So in my case, for the when I speak about customers, where the things I'm going to share about conversations, I speak with data engineers, database designers, DBAs. I know sometimes those are the same people in the company. Data scientists, a lot of business users, business analysts, data governance teams, things like that. So for us, we also speak SQL language. So we are more on the diagramming things, ERD diagrams, if you're familiar or not. It's called data modeling, but it's different data modeling, right? It's the visual modeling that I'm talking about. just kind of for your knowledge, there are different things people mean when they refer to data models. So I think that's a good distinction to make. So I had to Google this and go to Wikipedia to look at okay, data-driven, right? Because this is probably the most popular phrase we hear when a customer comes to us, looks at our solution. They're like, hey, so we're in this process. We just moved to cloud, or we're thinking of moving to cloud, and we have this goal of becoming data-driven. So what it means by Wikipedia, data-driven means that progress in any activity is compelled by data rather than intuition or personal experience. So, kind of goodbye intuition, no experience. Let's just, not trust our gut. Let's look at what data says. And, it could lead us to making a little bit more good decisions versus bad decisions in the way we structure our sales, the product, interaction between customer and the brand. There's a lot we could, get from the data. And I actually went to Google Trends also and looked at cloud analytics and data-driven. I did have a personal feeling that those, kind of have been growing exponentially. That's what the market tells us. And that's probably really 99% of the customer base our company, SQL DBM, interacts with. Those are the two things they're working on, getting their cloud analytics aligned and becoming, essentially at the end of it, becoming a data-driven company. So it's a fun journey, but there are a lot of caveats to that from both the technical and business points of view. I have just kind of to, I guess, prove that this is very wide of a trend. Just an example, I work with when I say I mean SQL DBM. We work with different industries, so it's not like there's a specific industry that's going cloud, and then everyone else does not. Really, I see financial companies, healthcare, education, government, sports, manufacturing, you name it, streaming companies, restaurants, packaged goods, really any company that's interacting with data, which is every company in the world, would want to kind of become data-driven at the end. So otherwise, it's just really the competition is going to eat you, because if they're looking, if they're making more precise data-informed decisions and you are not, at some point you'll lose to them, no matter how wonderful your product or your team is. So information is power, as they say. So yeah, again, different teams, business folks and IT folks, and then different industries that I'm talking about here. So essentially, everyone wants to go from data to information, to knowledge, to wisdom, and what it means. So you guys, again, from the technical point of view, I'll try not to really touch it too much, but from the point of view of business problems that we're trying to solve, this flow looks more like you record or try to record every customer interaction with your brand, right? Anything they do. Like, let's say if I talk about my waffle business from my life before, I would want to count, how many people came into the store, how many items they bought, for how much, which day of the week was the busiest one, did they return back, did they pay by cash or credit card? Like, every piece of information they provided me, or their interaction with my brand provided me, is essentially data for me there. Right? Did they go on the website before coming into the store, or did they check my Instagram account, or did they call? Right? Those things are all interactions with the brand. Really depends if you have an online brand or in person. Those interaction types could be different, yet what's common, and they will exist for any business. Then after you recorded those interactions, you'd want to quantify them. Right, so is it maybe like, is it an event? Is it how many times they came in? Is it the money amount? Right, you put some kind of specification to it, and then you want to combine the results. Right, so maybe you'd count all of your sales from the month, all of your sales from the year. Our BI folks would create beautiful dashboards with graphs, right, so that all with one goal, so that other people at the company can use that information. Also known as make decisions from that. And so when we talk about this, right, someone from your business team or business leader or marketing team comes to you and says, hey guys, we really need to count this leads from this source. Can you help us out? And we really need this in real time, and we need this tomorrow, and you need to help us, right? It helps you ask them right types of questions, because of course, us business folks, we sometimes don't know what really it involves, to get that information to us, to our fingertips, at the speed of light. We really expect maybe too much of our data teams, and hopefully with the education we can fix that problem later. But I also wanted to share a little example here. I'm reading this book. Maybe some of you know it, Rise of the Data Cloud, from Snowflake. From the CEO of Snowflake. And there's actually a chapter that says how to become a data-driven company. So I just underlined a couple of them. So the first step for companies is to get educated, to become proficient. Huge shift is happening right now, and they better get on it. The further you get behind the curve, the harder it is to catch up. So obviously you want to probably start with educating your people in the company, right, and get educated from all the levels, right, not only the C-suite. The next step they outline is hiring the right sort of people with the right outlook and skills, right? So you educate your company first on kind of the industry trends. You then hire the right people, or try to do so. Number 3, you need people with new skill sets deeper in the organization. So you'd hire data scientists, right? You would hire data engineers. You would kind of like not only hire a certain specific type of person or persona, and you would really want to get deep on that and wide probably. And then you would want to, number 4, they outline, you would want to train your frontline business leaders to learn how to use data analytics, because all business leaders, they want to have data analytics, they want to go to cloud analytics and be a data-driven company, but not all of them know what it essentially means on a deeper level. And then this book suggests that the next step is adopting a richly featured cloud data platform. Obviously, they have their own choice. I'm trying to be data agnostic, although here at SQLDBM we do work with more than 600 of Snowflake Data Cloud customers. So I definitely interact with those a lot. So just to summarize, right, educate your folks, hire the right people, get the right people with the skills, train your frontline business users about data analytics, and get some good tools together, and you should be fine, supposedly, right? And then I found this meme just today on LinkedIn in the morning. Really, what what business people think of data engineers, that if describing into words, take data from here, put it somewhere else. It's really funny, and I know it's more, much more involved than that. Maybe it looks more like this, right? For some companies, I've seen a lot of different ways of doing it, but it's definitely a little bit more than a 2-step process. And so at the end of the day, when we talk about aligning the teams, the business folks and the technical folks, about the cloud journey of the company, would probably want them both communicating. And there are some things that they both of these camps want out of those tools that they select. So whatever your data pipeline looks like, we've seen that majority of companies prefer it to be automated. Well, prefer is an interesting word choice here, but basically you would want to omit manual entry as much as possible, because it's just costly. You'd probably want your tools integrating with each other. No one wants a standalone tool anymore, right? You'd want kind of like more like an ecosystem, maybe. SQLDBM is definitely part of an ecosystem. Our tool is just one of many that would make up your ideal cloud, modern cloud data tech stack. Right, it would be just one of the tools, but we are aware of the fact that it's not going to solve 100% of the client's problems. They're probably going to align a couple of tools together and make them ideally talk to each other, right, and then automate that process as much as possible. Users, the business users, they want things in real time as much as possible. Again, a very, very interesting requirement. I do think it's possible. We've seen examples, and of course, choosing the right tool, maybe a cloud data platform would help you with that latency. Accessibility, definitely. You want your, once you actually combine and have your data together, you would want those pieces, those artifacts of metadata and data to be accessible to any team member at any time and searchable, right? So like if I'm a leader and, one day I need certain type of information, tomorrow I need a new, maybe new thing calculated, I ideally would want, in the ideal scenario, I would want to kind of get that information myself somehow. Again, it's not really possible without education and without the right tooling, but it is possible one day. And then self-serve analytics is where a lot of companies are trying to go. Again, it's a long shot, right? Just because if you could have an ideal set of tools, a great data team that prepared things together, but if your business users aren't really educated or aren't ready to use those tools, then you kind of wouldn't be there. Everyone wants an affordable tool, and it's great actually because cloud solutions, they do offer that flexibility. I've seen a lot of folks that we work with, a lot of competitors and compatible solutions. We try to charge whoever can. They either charge pay per use, right? So kind of like pay as you go. Snowflake does this, for example, right? You could get started with Snowflake, zero down, right? And then only once you start, storing and computing things, you would get charged for those separately. So technically, your cost, and same SQL DBM, for example, we do per license, per user cost, and it's not like a flat cost, right? It's like the more users you have, the more you pay. But if you only wanted to start small, and a lot of teams come to us and they're like, hey, we're just figuring out this process. We've got a couple tools aligned. We wanted to start small, right? They would get 2 or 3 users set up with the platform, would still spend a couple $1,000s only, and just kind of see if the tool brings them benefit, right? Because if they increase the usage, same, take Snowflake example. If you increase the usage, yes, you'll pay more, but this means that if you pay more and you increase the usage, it means you're getting more benefit. So benefit of using the product is really tied directly with the cost of it. So it's not kind of off. And that's what a lot of companies these days prefer when they procure solutions. Powerful, of course, if you're dealing with big sets of data, you would want to get powerful and fast solutions that perform well. We understood this, as our example, we understood this early on, and we just went live with a very big update just last week on simply, only on performance. Because of the fact that of that feedback we hear from customers, and especially if you're online, right? You're no longer desktop. It's kind of interesting to see things work much better than desktop solutions. So it's pretty fun to see. I put communication and collaboration kind of together. Again, because if as we're trying to bridge the gap between the IT users and the business folks. As you're building, as you're accessing the power of the cloud, you would probably want to pick solutions that allow for communication and collaboration, right? So that, you don't have to kind of send files, emails, and access outdated information, right? You'd want something real time. You'd want it searchable, accessible, collaborative. So kind of all of those things. Security is the last point here. It used to be kind of an arguable point, right? As we go cloud, like how secure are things? I'm not going to talk too much about this, but I just know that all of the partners we work with, our solution, for example, they take security very seriously, and you'd have like a whole team take care of it. And we, for example, SQL DBM, we underwent a rigorous third-party evaluation. We've got SOC 2 Type 2 compliant and certified, which kind of helps us stand out as a cloud solution. So again, probably if you are looking at a cloud solution, you'd want to kind of look out for that certification, for that compliance thing. So yeah, that's pretty much it. Really, I hope I didn't go over time. I don't know if anyone's still here. This is fun. So again, solutions that are, in examples of criteria that people use and teams use when they look for a solution, simply our experience. I'll tell you though that our experience is based on more than 200,000 users out there of SQL DBM. So I hope that's an adequate sample size for you. And I do want to end with the recommendations. Okay, right here. So if we talk about recommendations, definitely recommend the book, Rise of the Data Cloud. Obviously, it's it's from Snowflake, so it talks about Snowflake a lot, but there are a lot of interesting stories of companies and industry leaders that are highlighted. I really enjoyed reading about those. If you are considering to or your company may be going through, migration, or just completed one. My colleague Serge, he wrote a beautiful piece of, kind of actionable advice, because he has that experience of moving from on-premises to cloud, to Snowflake actually, and so he shares that advice in a very profound article. And then another thing I'll highlight, the Data Chief from ThoughtSpot. They're very cool, and I do like seeing this content there. So, that's my friendly recommendation for those resources.
Well, thank you so much, Anna. That was amazing, and it's our first time having a presentation done on a Miro board, and I thought that was pretty awesome. Actually, really well done. It's just a great interactive way to sort of zoom in and out of concepts, isn't it?
Yeah, I kind of get tired sometimes of like clicking through slides. So I'm trying to do it as productive, as interactive as possible. So you let me know how that works.
No, that was fantastic. Yeah, we'll get some community feedback on it, see whether it becomes like more of a thing in the future. I know definitely,
better be.
Yeah, that's it. No, that was great. I love the, sort of, I guess the sort of the considerations that you were sort of walking us through, and also the books. It sounds like you talk to not only, some technical folks, but you're very business facing, and, you're talking to people in the C-suite. Maybe they don't have deep knowledge of some of the technical issues around data and things like that. And, you mentioned a couple of great books as resources and things like that people can sort of leverage. And, like the Data Cloud by Frank Slootman, isn't it?
Yep.
The CEO of Snowflake.
Yep.
Yeah.
I have it right here.
Wowza. Okay.
Yeah.
So you go to during the day for quotes, I guess.
And post them on LinkedIn later. Yeah, that's what.
Yeah, nice one. It's from Anna. Any recommendations in that front, other than what you've sort of, or recommendations for data engineers? Maybe they're not sort of getting their ideas across to, I guess, the business folk, in the company. Any recommendations for strategies on how to bridge that gap, other than just kind of rewatching your talk on replay all day long?
Definitely the communication. Just kind of, I've heard this somewhere, and I couldn't quote the source, but pretty much start with great data stories starts with good questions. And so, maybe asking your business folks of like, hey, why do you need this type of information? And like, what's the story behind it, of like, what type of decisions you're trying to make, right? Sometimes would give you a little bit more insight into kind of what their job is all about. And then if you know that, you can actually help them maybe more than if you just assume things.
Yep. So ask lots of questions and really sort of start the engagement earlier. So, down that command line terminal and actually go out and maybe talk to
maybe just
folks.
Slack them. Maybe just Slack them. You don't have to like talk to them face to face. Just Slack them a question.
Keep your hands on the keyboards and stuff like that. You don't need to quite exit away from the computer. Good to know. Good to know. I might take some of that advice on board one day. No, awesome. Well, it's probably due to the fact that you're the second speaker. We've had a slow sort of slow day on the questions coming through on the YouTube stream, but I think it's just a bit of a hallmark of the times we're living in. People are kind of like sort of coming in and out, and they'll probably watch the presentations a bit later on as well. So
we're good, so I don't have to embarrass myself with weird answers. All good.
Yeah. It's usually just me embarrassing myself on these live streams, but it's great to have such awesome speakers here with us today. So thanks so much, Anna. Thanks, Brian. Really enjoyed both talks, and keep us posted. Data engineering community out there. If you've got any ideas for future talks or you'd like to do a talk at a later date, just come say hello. Definitely stay tuned for announcements about DataEng Bytes. That's coming up. We're converting it to a 3-day conference from the 5th to the 7th of October. So stay tuned for announcements on that one. Thanks once again to Anna. I really appreciate you taking the time out to speak to us today.
Thanks, Peter. Have a good one.
Ciao for now. Bye.